All right, welcome. Today we're going to jump into something that's a real cornerstone of algebra, adding and subtracting polynomials. Now, it seems simple, right? But there's this one little thing, what I call the subtraction trap, that can trip up even the sharpest students. We're going to break it all down and show you exactly how to avoid it. So let's get right into it.
But first, let me ask you something. What in the world does figuring out a company's profit have in common with something like x squared? I mean, they seem like they're from completely different planets, don't they? Well, it turns out they're connected by the very skill we're about to dive into. Just hang on to that thought. We'll come back to it at the end.
Ed, here's the great news. You're not starting from scratch here, not even close. Adding and subtracting polynomials is all built on a skill you probably already know pretty well, combining like terms. Seriously, if you know that 3x plus 5x is 8x, you're already halfway there. We're just going to take that exact same idea and apply it to some bigger expressions.
So before we get into the whole polynomial shebang, let's just do a quick refresher on that core concept of like terms. Nailing this fundamental piece is absolutely key because everything else we do today builds on it.
So what exactly are like terms? Well, the key here is that they have to be perfect twins. I mean, they need the exact same variable raised to the exact same power. So something like 3x squared and negative 7x squared, yeah, they're like terms. They both have that x squared. But what about 3x squared and 3x cubed? Nope, not going to work. That tiny difference in the exponent, that 2 versus the 3, makes all the difference in the world. It means they're not a match and you just can't combine them.
Now, when it comes to adding polynomials, it's actually kind of nice. It's so straightforward. You literally just drop the parentheses, poof, they're gone, and then you just go on a little scavenger hunt, grouping up all the like terms you can find. That's it. It's really just about organizing and adding.
Okay, so addition is in the bag. Now for the main event, subtraction. This is where, the alarms go off. This is where most mistakes happen. But it's not because it's super complicated. It's because of one single crucial step that is just so easy to forget. We're calling it the subtraction trap.
Okay, if you remember one thing from this whole explainer, let it be this. This is the big rule. When you subtract a polynomial, you have to flip every single sign in the expression you're subtracting. Every single one. Positives turn into negatives, and negatives, well, they turn into positives. This is the absolute key to avoiding that trap.
And you might be thinking, hold on a second. Why? Why do all the signs have to flip? Why can't I just subtract the very first term and call it a day? And you know what? That's a totally fair question.
The answer comes down to one really powerful idea in math: distribution. You see, that little negative sign out front isn't just attached to the first term. You have to think of it like a -1 that's being multiplied by everything inside those parentheses. It has to be shared or distributed across every single term. And here it is. This is that common trap in action. The big mistake is just applying that negative to the first term, the 2x squared, and then just forgetting about the plus 5x. The right way, the only way, is to distribute that negative to both terms. That changes the plus 5x into a negative 5x. I'm telling you, that one little step makes all the difference.
All right, enough with the theory. The best way to really get this stuff to stick is to see it work. So let's walk through a few examples together. We'll start with a nice, easy addition problem, and then we'll jump in and tackle that subtraction trap head on.
Okay, first up, a simple addition. Since it's addition, we can just get rid of the parentheses right away. Now we just play matchmaker. We'll group the 4x cubed with the x cubed, then we've got the 2x and the negative 5x, and finally the constants, -9 and +3. We combine each pair, and there's our answer. 5x cubed minus 3x minus 6. See? Not too bad. All right, now for a subtraction problem. See that minus sign? That's our cue. We have to distribute it to everything in the second parentheses, so the 2x squared becomes negative 2x squared. The plus 5x becomes negative 5x. And here's the one people always forget. The -1 flips to become a +1. Once all the signs are flipped, it's just like the addition problem. Combine the like terms, and we get our final answer. Okay, let's do one last example. This one uses what's called function notation, f of x and g of x, but don't let that throw you off. The process is exactly the same. It just adds one extra little twist to watch out for, the dreaded double negative.
So we just set it up, f of x minus g of x. Now watch this part closely. As we distribute that negative, it hits the negative 3x cubed, and what happens when you have a minus and negative, it becomes a positive. So we get plus 3x cubed. The other signs flip like we expect. From there, it's business as usual. We combine our like terms and just write the final answer in what's called standard form. That just means from the highest exponent down to the lowest.
So let's do a quick recap of the key takeaways here. To really get this down, it all boils down to remembering one main idea and making sure you avoid two very, very common mistakes.
So, to wrap it up, the two biggest mistakes you want to watch out for are, number one, forgetting to distribute that negative sign to every single term when you subtract, and number two, getting a little too excited and combining terms that aren't actually alike. Just remember, x squared and x are different things. They have to stay in their own separate lanes.
Okay, remember that question from the very beginning about business profit in algebra? Well, here is the big reveal. The formula for profit is actually super simple. It's just revenue minus cost. So if you can represent your company's revenue with a polynomial, let's call it r of x, and your cost with another one, c of x, how do you find the profit? You subtract them. P of x equals r of x times c of x. It is literally polynomial subtraction. This abstract algebra skill is actually used to model real-world money. How cool is that?
So there you have it. You've just mastered a critical building block in algebra. And once you know for sure that you can add and subtract these things, well, the next logical question is, can you multiply them? And that is exactly where this journey is headed next.